Oh, I'm Mark Howitt, and Jeff Draper's somewhere around here. We've got an exhibition stand right at the furthest corner of the main room, so you're welcome to come and see us afterwards. We're the founding directors of Storelectric Limited, and our purpose is to make renewable energy profitable and also to make traditional energy efficient, which are the two holy grails of the current energy crisis. Essentially, the problem is the scale of it. We are generating gigawatts of intermittent power, in which the generation is completely regardless of when you actually want to use the electricity. In order to support the national grid, we therefore need to keep fossil fuel power stations in reserve as backup on very low levels of utilization and decreasing levels of utilization, and therefore plummeting profitability, which is why all the German utilities are closing all of their gas-fired power stations, and there's only a couple of gas-fired power stations forecast to be built and opened in the UK in the foreseeable future to replace dozens of power stations retiring. So the scale has been identified by George Osborne as a solution would benefit the whole electricity industry alone by £20 billion a year, £10 billion a year by 2050. And Imperial College reckon that the whole economy would benefit by £60 billion a year by 2030 by solving this problem of matching intermittent supply with variable demand. The solution is compressed air energy storage. This is the only one that can do it at such scale. All other solutions currently being backed around the country are at megawatt scale. This is a gigawatt scale. Each one of these installations will be 500 megawatts for about 21 gigawatt hours. So you're able to run backup for 42 hours, that is 14 consecutive peaks in demand between replenishments. So you can go through really bad weather periods, so no generation, and still do it. The compressed air energy storage is all about taking surplus electricity when it's being generated and not wanted off the grid, or even direct in-feed from wind farms and such like, using the power to compress air to 70 bar, which is about 30 times the pressure of your car tire. That air you put down in a salt cavern, which is of its very nature hermetic. A large proportion of all the natural gas stored around the world is actually stored in salt caverns, and they've never leaked. So that is identical technology, well proven over about 50 years of storing natural gas, and we're just putting air down there. When we need the electricity, we expand it and use that expansion to generate the power. Now, the key to the problem is not in the compression and the expansion of the air. The key to the problem is in the heat, because when you compress the air to 70 bar, you raise the temperature to roughly 800 degrees. When you expand it from ambient, you drop the temperature down to about minus 170, which is a bit cold. So what we do is we recycle the thermal energy, take the heat of compression in our thermal management system and store it to put back in during expansion. And that way we can hit round-trip efficiencies of 68 to 70%, underwritten by Siemens as being feasible using existing off-the-shelf equipment, which minimizes the technical risk. So it's the world's biggest battery, and all it uses is air, water, salt, and equipment. Nothing else. Completely benign. The directors are myself and Jeff Draper. We're both physicists. We've both been in various different types of industry with track records of starting up businesses and subsidiaries that have worked exceedingly well. Our chairman is David Weaver, who set up BP Renewables and has been involved in an awful lot of green energy startups successfully around the world, taking them to market and taking them to trade sale or flotation. Professor Phil Lee, Director of the Irish Sea Rim Programme and the Energy Demonstrator Programme in Chester University, who was part of the Energy Demonstrator Programme without a penny of cost to us. They are building a 0.5 megawatt prototype demonstrator to be used as an experimental system on which to develop new technologies, and we've got a whole raft of new technologies that we want to build, but we don't want to do them until after we've got our first installations, because we've got adequate efficiencies to be able to minimize the risk. And David Pickering has also been involved in many startups, so that's the team, very experienced in this. But more importantly is our consortium. Siemens say that they can make it using their current technology, and they can achieve the efficiencies, 68 to 70% round-trip efficiency for that scale, using existing catalogue equipment. And they've said so publicly on video. We've got the video playing at our stand. PricewaterhouseCoopers have committed to an enormous amount of work on our behalf without charge in return for some equity. They don't normally give their time away. Denton's one of the biggest legal firms. They're taking at-risk free legal advice to help us get off the ground for later repayment. Oswald Consultancy is a specialist business that Mr. Oswald used to be the R&D director for Rolls-Royce Energy, and he can draw on that whole former team that stayed behind when Rolls-Royce Energy moved to Canada. One of 5 multinationals in the civil engineering space. The current leader is actually Balfour Beatty, who are exceedingly interested in joining, but so are the likes of Ilian, Amy, AMEC, and Arab. One of 2 engineering multinationals to support the thermal management side, that's Areva and Alstom. So they're all extremely interested. Every one of these is under NDA, and getting an NDA out of these companies is blood out of a stone. And also the world's largest chemical manufacturer, who is actually offering us existing salt caverns on which to build it, and salt caverns with a capacity of between 4 and 8 gigawatt hours, expandable to about 60. We've got 4 universities involved, and various comments about Storelectric. DEC say that it's the only viable technology at truly grid scale in the world at the moment. PricewaterhouseCoopers saying that they've been very aware of the market for a very long time and have never, until they came across us, seen a potential solution to satisfy that market. Siemens, the components are available, the caverns are available, it does work, and it will work. Direct quotes off the video that's available publicly. And National Grid saying that it satisfies their urgent needs for supplying, keeping the lights on basically. So what we have, 8 patents on the way that are process patents using existing proven technologies in the field at the right scale, but in a novel configuration. Both Siemens and Oswald have commented that they've never seen thermodynamic cycles like it, but it works. Siemens have underwritten 63% efficiency for a 40 megawatt pilot plant. Efficiency grows with scale, 68 to 70% for the 500 megawatt plant. Vacant salt caverns in the northwest of England, and lots of other vacant salt caverns elsewhere, and opportunities throughout the world. 21 gigawatt hours minimum storage per installation, very efficient as the best of them. Our expertise in the team is tremendous. The market is about 17 gigawatts initially in the UK, with about 700 gigawatt hours of storage, in order to level out, match all of renewable generation, intermittent generation, with all of variable demand. The ability to replicate it throughout the country and the world, and an extremely strong business case. The business model, each rollout, 500 megawatts, will be a self-financed SPV, which would not dilute the main company and would actually generate revenues back to the main company. Plenty of profits for the 500 megawatts scale plants, the profits even for the pilot plant, and most of that will be debt financed with the likes of pension funds who have already expressed interest in financing it at low interest rates because of the certainty of the technology and the fact that it's infrastructure. In 2 to 3 years from funding, we can have our pilot plant trading profitably. Another 4 or 5 years later, we will have the first full-scale plant trading. We will be negotiating further full-scale plants while building the pilot plant. There is a lot of interest in doing so and roll out throughout the world. We're raising £1.5 million now. The full pilot plant would be 20 to 40 million pounds, depending on the extent of the in-kind contributions, and the £1.5 million will get us to that fundraise, and that fundraise will be to build the full-scale plant. Thank you very much.
Great. Mark, thanks very much for that. Very interesting. I've got a question for you. I think we can probably all understand how you might approach capital markets with your full-blown 500 megawatt plant when it's proven and the asset class is understood. How are you going to fund the pilot plant at that 30 million raise? Because that's the bit that's the intermediate funding bit, which will be much more difficult to find finance.
We're already talking to a number of VCs who are interested in funding that. The work to be done with this initial work would be considered working capital that would give them the comfort behind that to fund it. A couple of them are actually considering funding it upfront now and just using the £1.5 million stage as a stage payment. So we're already interested in that. We've got Siemens, Ineos and Balfour Beatty who are all considering whether or not to put in a financial contribution, but they're all certainly going to be putting in-kind contributions.
David?
Just wondered if you could say something about what you've built so far to validate your model, and if there's any plans for anything at intermediate scale to de-risk some of the larger users.
So far what we've done is we've run the actual performance data from actual existing Siemens catalogue machines through the cycle through computer models, and identified that those are the efficiencies that can be achieved with such certainty that Siemens are asking the question, why bother with the pilot plant, why not go straight to full scale, which they can also build off the shelf. But though we do believe that we need the pilot plant. So what was the second question?
I just wondered if there was something that was smaller than 40 megawatts that may de-risk the proposition from a build point of view rather than...
Chester is building a 0.5 megawatts demonstrator, but we want to do that in parallel. The thing about compressed air energy storage, unlike batteries, is that efficiency is proportional to size. So if you go down efficiency by a factor of 10, size by a factor of 10, you're removing 6 to 8% of efficiency. And you downscale it too much and it won't pass a silhouette test. So we're looking at building the 40 megawatt pilot plant as a first off, but that will be, in America they've got 3 companies that have had $250 million worth of funding over the last 7 years and managed to build 2 megawatts with over 50% downtime. For less than a third of that, we'll build 40 megawatts that will operate at well over 95% uptime, and be the biggest plant in the world of its kind.
One final question?
Yeah, just thinking about the sort of self-financed SPVs, I might have missed it, but presumably if you're going to get that quantitative finance in there, you're going to need long-term revenue contracts. So where are you in terms of discussing what is available sort of for that period of time and who the counterparties would like to be?
We're already in negotiations with National Grid, who are working hand in glove with PwC to identify the funding streams that they can guarantee for the period. They've already proposed to us setting in place conditional contracts for call-off of power that will satisfy those investors. So that's already in hand with discussions ongoing with the National Grid.
One more question.
Go on.
So I guess the danger with these very big things is that you're basically doing very extensive market research for much bigger players. Because all of this is off the shelf, and it's a lot of innovation game, and nothing better around it. But I'm just wondering to what extent your model could be pivoted more towards an engineering consultancy model, that you could be the best in the world doing that. Because there's a lot of big things that you're trying to achieve, and there are really big players out there that.
Well, effectively, the SPV model is a kind of consultancy model. We're licensing out the IP, we're teaching them how to do it, we're supporting them in doing it. We would have a minority stake in the SPV, a large one, but a minority stake, because that would get around competition issues worldwide. We wouldn't have a say in pricing for the same reasons. So we are consulting on getting it done as efficiently as possible, but we're also owning a stake in the company in exchange for our IP and know-how.
So you're not a technology company?
Sorry?
You're not a technology company?
We will own the technology, we own the IP. We will have the expertise within our team in order to achieve it. We will build it. We will frequently build it using our partners, or frequently using the partners within the SPV. But yes, we will build it, we will own the technology, and we will continue to developing the technology. We have a whole program of R&D to be undertaken after we've got the first one up and running, but we don't want to do it before the first one's up and running because we want to minimize risk.
Great, well thanks very much, Mark. That was a very interesting talk, and let's give it a hand for all our speakers.